Okay, sorry about that. The camera just decided to die in the middle of me doing this lesson. Sorry. So I'm going to have to do it over. We're sketching acceleration, velocity, and position graphs for a rock that's being thrown horizontally off a cliff, right? Horizontally. So what I said was its acceleration is negative 9.8, so that's a negative. I mean, I don't have to put any numbers on here necessarily. It said sketch. When it says sketch, I think it means you don't have to worry about numbers, but it should be a constant negative 9.8. That's what this is showing. In the x direction, it's not being accelerated. There's no little rocket on its behind pushing it in the x direction, so its acceleration is 0. So if the acceleration is negative 9.8, then the slope of its vertical velocity would be negative 9.8. So some sort of line like this with a negative slope, right? Starting at 0 in the y direction and then picking up speed in the negative direction. In the positive direction, it's just going at some positive constant speed that it was launched at. And that doesn't change because the acceleration is 0. And so for our position, we're going to start off at 0, and then we're going to have negative position. So we're going to increase our negative position so that our negative position is picking up. And in the positive direction, we're just picking up positive displacement. A second rock is now thrown at an angle theta above the horizontal with the same speed v from the same height h as the rock in part A and the same set of axes in part A. Sketch the graphs of the second rock. If the graphs for part B are different, then part A use different colors or different lines to differentiate between the lines in part A and part B. All right, let's see. Well, let's see if I have a marker that actually works. Oh, wow, I do. All right, so this is going to be so for the second rock, which is thrown up like this, the acceleration in free fall is the same. And is it thrown at the same speed? Same speed. So actually, its x velocity, it's going to have an x component, right, to its velocity. So this leg has to be smaller than the hypotenuse. So it's actually going to be, well, the acceleration is still 0. Yeah, it's not going to accelerate in the x direction, but its velocity is going to be something less, right, because now it's only a component. The x velocity is now only a component of velocity. And in the y direction, we actually do now have a y velocity to start with. It's not 0 anymore, but again, it's going to have the same slope. Well, that's supposed to be the same slope, right? It's going to be, the slope of this line should be negative 9.8, just like this one. It's just going to start with a positive velocity. And it's going to hit 0 at some point when it goes to the top and stops, and then it's going to pick up negative velocity. Right, and again, now we're starting at 0, and we're going to go up like this. Right, we're going to go up in the air first, and then flatten out, and then come back down. Sorry. And in the x direction, this is pretty much going to be the same thing. It's just probably just not going to go as far. So maybe we have a shallower. I'm thinking just kind of off the top of my head, I think we're going to have a shallower slope like that. All right, if the second rock was thrown horizontal with 2v, with the horizontal distance d between the bottom of the cliff larger, smaller, the same as first rock. Second rock was now 2v. Okay, so the second rock is now, so forget about throwing it at an angle. Now we're going to throw it horizontally, but we're going to throw it twice as fast. The horizontal distance, well, the distance is the velocity times time, and now we're going to increase that, so yeah, that would be larger. D would be larger. Evidence, the time to fall is controlled by the cliff, right? How long it takes the rock to fall off the cliff if we're throwing it. The time for both rocks is the same, so the height. The height for both rocks is the same, so the time to fall is also the same. Since both rocks are in the air for the same time, the rock that is going faster, B, goes further.